Tonight, as you lie in bed and your mind begins to gently relax, we will explore one of the most fascinating and mysterious corners of human consciousness: hereditary memory. Could it be that we carry not only physical traits, but also the experiences, fears, abilities, and intuitive knowledge of our ancestors encoded in our genes? For the next hour, we will embark on a calm, slightly mystical journey into the depths of our DNA, at the intersection of science and intuition. Close your eyes, take a deep breath, and begin to listen to the whispers of your ancestors. Memories from another life, whispers of ancestors. We have all felt that strange sensation, haven't we? Déjà vu, the feeling of "I've been here before." A moment lasting only seconds, yet so powerful it feels like a memory from another life. A street corner, a melody, or a face. Your mind whispers to you, you know this. Sometimes these experiences go even deeper. A place you have never visited feels strangely familiar, or a skill you have never learned comes naturally to you. As a child, your hand instinctively forming shapes while drawing. Could these be echoes of forgotten lives coded within us? Ancient wisdom and mystical traditions have debated this idea for centuries through concepts of rebirth or the collective unconscious. Tonight, however, we will explore the scientific potential behind these feelings. Consider this. This familiarity might be a spiritual connection, but it could also be a biological legacy hidden deep within our brains and genes. Just as a tree carries the knowledge of past seasons in its seeds, we might carry the stories of our ancestors within our genetic memory. Pause for a moment and ask yourself, what in your life evokes an inexplicable sense of familiarity? 2. Unlocking the blueprint within our physical features: eye color, height, the curl of our hair are explicit instructions in our DNA. But modern science shows that inheritance contains far more. The invisible force shaping us is epigenetic inheritance. Epigenetics studies how genes are turned on or off without altering the DNA sequence. Simply put, if your genes are your hardware, epigenetics is your software. Environmental factors, lifestyle choices, and profound experiences can update this software, and these updates can be passed to the next generation. Some of the most striking research focuses on trauma. Intense stress, famine, or war experienced by previous generations can leave lasting marks in our genes. In experiments with mice, offspring of parents who were conditioned to fear a specific scent also exhibited fear of that scent even though they had never encountered it in humans. Descendants of Holocaust survivors or families affected by severe famines show inherited markers of anxiety, stress, or metabolic changes. These findings suggest that the experiences of previous generations leave traces in our biology. Our unexplained anxieties may be echoes of our ancestors' struggles and survival instincts. But inheritance is not limited to trauma. Courage, resilience, and even artistic talent might also be passed down, silently shaping who we are. The skills and adaptations of our ancestors resonate quietly within us. 3. Decoding your hereditary instincts. Let's apply this knowledge to our own lives. Consider fears, phobias, or abilities that seem to have no clear origin. Why do some people fear confined spaces, water, or certain animals? Many fears can be explained through personal experiences. But what if a small fraction of these fears stem from your grandfather narrowly escaping drowning, subtly influencing your water anxiety today? Imagine a child whose parents never learned to play the violin, yet the child demonstrates innate rhythm and musicality. Could this be mere coincidence? or the quiet echo of a talented distant relative. Case studies and personal stories are beginning to reveal these connections. Therapists sometimes suggest exploring ancestral stories to resolve fears and grief that are not originally one's own. Remarkably, individuals who become aware of their ancestors' losses often experience relief from unexplained depression or anxiety. A brief thought experiment. Lie down comfortably. Focus on the following questions. What is your greatest, most irrational fear or anxiety? Which of your talents seems to have no apparent origin in your family? What habits or emotional patterns repeat across your ancestors' generations? Discover your genetic heritage and harness it to grow your personal strength and potential. Think like a historian. Understanding an event's origin allows you to manage its present-day impact. Embrace your ancestors' survival, not their fear. Nurture their gifts, not their burdens. You are the strongest, most adaptive version of your lineage. V. Integrating ancestral wisdom. As we near the end of this journey, consider how you can integrate these insights into daily life. The goal is to peacefully connect with your genetic memory while preparing for restful sleep. Practical exercises to try in bed. Reflect on recurring dreams. Could they represent unresolved stories from your ancestors? Offer them your love and peace. Observe with mindfulness. When sudden anger or sadness arises, ask, is this truly mine, or is it a memory? This simple practice lightens emotional weight. Affirmation and gratitude. Whisper your thanks to your ancestors for surviving and giving you this life. As science progresses, technologies may allow us to read genetic memory. Which memories will we choose to inherit? Which burdens will we leave behind? These are questions for the future. For now, remain in this moment, fully present. Vi. Journeying to sleep with ancestral whispers now. Slowly close your eyes. Let your body sink into the mattress. Relax your hands and feet. Feel your body from the crown of your head to your toes. Heavy, calm, and peaceful. Take a deep breath in and exhale slowly. Let your breath flow like gentle waves. Calmness in, tension out. Filling yourself with serenity. Imagine your ancestors' whispers softly brushing your mind. Their wisdom, courage, and resilience wrap around you, embracing and protecting you. Focus on your body, your feet, legs, torso, arms, face. Each muscle, each cell, releasing tension, surrendering to deep relaxation. Reflect gently. Release emotions you cannot carry today. Observe ancestral fears and thank them, then release. Sense the talents and gifts they've passed to you. With every breath, feel yourself filling with quiet energy. Your mind calm, your body heavy, drifting closer to sleep. Now, fully close your eyes. In harmony with your breath, let the whispers of your ancestors guide you into the dream world. Safe, peaceful, and serene. Now. Slowly close your eyes. Let your body sink into the mattress. Relax your hands and feet. Feel your entire body, from the crown of your head down to the tips of your toes. With each breath, your body grows heavier, more grounded, more at peace. Take a deep breath in and exhale slowly. Follow the rhythm of your breathing. Let it flow like gentle waves, calmness flowing in, tension flowing out. Peace fills you while worries drift away, dissolving into the air around you. Now, imagine the soft whispers of your ancestors brushing gently against your ears. The wisdom, love, and resilience from their lived experiences meet you here, enveloping you with warmth. With each breath, these whispers wrap around you like a protective, gentle embrace. Bring your awareness to your body, your feet, your legs, your abdomen, your chest, your arms, and your face. Each part slowly loosens. Each muscle releases. Each cell surrenders to deep relaxation. A wave of calm spreads from your head to your toes, leaving only stillness and comfort in its path. Now, open your mind gently and reflect. Is there an emotion you've been holding on to today? Simply say, "Thank you," and let it go. Are there worries from the past lingering within you? Notice them, but choose not to carry them any longer. Feel the talent and power inside you, the gifts your ancestors have left for you. With every breath, let this quiet, peaceful energy fill you. Each inhale brings calm. Each exhale releases tension. Your mind grows quieter. Your body grows heavier. And with each gentle wave of breath, you move one step closer to sleep. Now, close your eyes completely. In harmony with your breathing, let the whispers of your ancestors guide you softly into slumber. Imagine drifting into a safe, peaceful dream world where every thought and worry gently fades. Pause 5 to 6 minutes. Background music slows, accompanied by soft water and wind sounds with a gentle, slow breathing effect. Speaker, now, focus entirely on your breath. Let thoughts come and go like passing clouds. Embrace the stillness and peace within. You have released the burdens of the past. You have welcomed the present and embraced the possibilities of the future. It is time to rest completely. Let your soul be serene. Let your dreams be bright. Sleep well. Positive epigenetic inheritance, resilience, and evolutionary advantage. The idea that epigenetic inheritance only transmits the scars of trauma is only half the story. Research shows that the ability of ancestors to successfully adapt to harsh conditions can also be passed down. Evolutionary advantage. An ancestor who overcame a period of severe illness or famine may have optimized the gene expression mechanisms in their body. This optimization can be passed down to descendants as a more efficient metabolism or a more robust immune system. This can be thought of as a kind of genetic vaccine or resilience code. Descendants inherit not the hardship itself, but the strength to withstand it. 2. Epigenetic triggers. The speed of lifestyle and sex. Differences. Epigenetic changes can occur and be inherited in a matter of months, not just decades. The speed of the father's lifestyle. The father's sperm cells are extremely sensitive to environmental factors like diet, stress, and toxin exposure in the months preceding conception. A father having children at an older age can lead to changes in DNA. Methylation tags chemical switches that control the on-off state of genes in the sperm. These changes can increase the risk of neurodevelopmental disorders like autism or schizophrenia in the children. Sex differences. Research suggests that epigenetic marks inherited from the mother are sometimes more stable than those from the father. However, those transmitted by the father can lead to faster and more dramatic changes, especially concerning stress and metabolism. 3. The fourth generation effect and intergenerational healing. It was once thought that the epigenetic effect faded after one generation, but some studies indicate that the impact can persist up to the fourth generation. Opening parenthesis great-grandchildren closing parenthesis potential for healing. This long-lasting effect is also a source of hope. If a trauma is transmitted through 4 generations, then conscious healing and healthy lifestyle choices also have the potential to leave a positive imprint for the same duration. The cycles we break and the resilience we develop in our own lives can biologically affect not just us, but the next 4 generations. For INTEGRATIV approaches, somatic experiencing and family constellations and psychology. Approaches that address this topic by combining science with intuition are gaining popularity. Somatic experiencing. This type of therapy is based on the principle that trauma is not only mental, but an energy stored in the nervous system and body. Traumatic responses inherited from our ancestors, for example. A constant state of hypervigilance often manifest as physical freezing or overarousal in the body. Somatic therapy aims to release this old energy through body movements and awareness. Family constellations. This integrative method posits that an individual's anxieties stem not from themselves, but from unresolved exclusion, loss, or injustice within the family system. This therapy centers on the idea that an individual's emotional burden might actually be a loyalty or entrustment passed down from ancestors. Recognizing this burden can profoundly free the individual. Human memory represents one of the most complex and essential functions of the brain, serving as the repository for experiences, learned information, and emotional traces that shape our identity. While the anatomical and functional architecture of memory has been extensively mapped in recent decades, the underlying biological and molecular mechanisms that govern memory formation, storage, and retrieval remain incompletely understood. Memory processes occur across both cortical and subcortical regions of the brain, which operate not only in parallel but also in coordinated networks. These regions are characterized not only by their functional connectivity but also by distinct genetic profiles. Cortical and subcortical memory regions contain both shared and region-specific gene signatures, which are increasingly recognized as central to understanding how memories are formed and maintained at the molecular level. A recent study published in provides new insights into how the human brain encodes memories and highlights potential candidate genes for future research into cognitive function. The study by Tan and colleagues aimed to systematically identify gene signatures associated with human memory by analyzing gene expression patterns in memory-related cortical and subcortical regions. To achieve this, the researchers leveraged the Allen Human Brain Atlas, a comprehensive resource containing expression data for approximately 24,000 genes across multiple brain regions. Using advanced bioinformatics approaches, they refined these data to isolate gene signatures uniquely associated with specific memory regions. The analysis revealed distinct sets of genes expressed in cortical memory regions, such as the entorhinal cortex, and subcortical memory regions, such as the hippocampus. Genes expressed in cortical areas were predominantly involved in transcriptional regulation, synaptic plasticity, and glutamate receptor signaling processes that are critical for learning and long-term memory consolidation. In contrast, genes in subcortical regions were primarily associated with neurogenesis and glial cell differentiation. Glial cells, which provide essential support to neurons, play a crucial role in maintaining neuronal health and facilitating efficient neural signaling. Interestingly, the study also identified a subset of genes that are shared between cortical and subcortical regions. challenging prior assumptions that these regions functioned with entirely independent genetic programs, although the proportion of overlapping genes was relatively low. These shared genes appear to play a central role in supporting the integrated function of memory networks. By examining both unique and overlapping gene sets, the researchers were able to gain a more holistic understanding of the molecular architecture of memory, to establish spatial correlations between macro-scale neuroimaging data and micro-scale gene expression. The research team employed an unsupervised system that mapped functionally defined genes in cortical and subcortical memory regions. This approach revealed that cortical gene expression was largely associated with immune signaling pathways and calcium transport, whereas negative gene regions were linked to epigenetic regulation. In subcortical regions, expressed genes were primarily involved in neurogenetic processes and glial differentiation. These findings suggest that memory-related gene expression is intricately linked to both cellular and molecular mechanisms that support cognitive function. The validity of these findings was further supported by studies in animal models, which confirmed that the identified genes significantly contribute to controlled cognitive processes. By comparing differences and overlaps between cortical and subcortical memory gene sets, the study highlighted the importance of genetic interactions in underpinning memory functions. Overlapping genes, in particular, may serve as essential regulators of the integrated neural circuits required for encoding and retrieving memories. Overall, this study provides a human-centered framework for understanding the genetics of cognitive systems. By identifying distinct and overlapping gene sets in cortical and subcortical memory regions, it opens avenues for future experimental studies to investigate potential gene candidates associated with memory-related disorders. Moreover, these insights offer a foundation for exploring novel therapeutic targets in neurological diseases and enhancing our understanding of the biological basis of memory. The integration of neuroimaging, bioinformatics, and molecular genetics exemplifies the emerging interdisciplinary approach necessary to unravel the complex mechanisms underlying human cognition. conclusion, the intricate interplay of genes across cortical and subcortical regions illuminates the profound complexity of human memory. Each memory we form, whether a fleeting thought, a learned skill, or a deeply emotional experience, is supported by a delicate network of genetic expressions that guide synaptic plasticity, neurogenesis, glial cell function, and epigenetic regulation. Cortical regions, with their emphasis on transcriptional regulation and glutamate signaling, enable the consolidation and retrieval of detailed, long-term memories. Subcortical regions, enriched in genes governing neurogenesis and glial differentiation, provide the foundational support for memory formation, learning, and adaptive responses. Together, these regions and their overlapping gene signatures form a harmonized system, ensuring that our cognitive and emotional experiences are encoded, maintained, and accessed with remarkable efficiency. Recent studies, including those validated in animal models, underscore that even a small subset of overlapping genes can have profound effects on memory function, highlighting the interconnectedness of cortical and subcortical networks. Understanding these genetic signatures not only enriches our comprehension of memory, but also opens new avenues for research into cognitive disorders, neurodegenerative diseases, and potential therapeutic interventions. By mapping these gene networks, scientists are beginning to uncover how memories are biologically structured, stored, and adapted across the human lifespan. Now, take a moment to bring this knowledge into your own awareness. Gently close your eyes and take a deep, slow breath. Allow yourself to visualize your brain as a vast, interconnected network of neurons and glial cells, with genes acting as the silent conductors orchestrating each signal, each connection, and each memory. With every inhale, imagine drawing in clarity, insight, and curiosity. With every exhale, release tension, doubt, or distraction. Picture the cortical regions lighting up as they process new information, and the subcortical regions quietly supporting the foundations of memory, learning, and adaptation. Sense the harmony between structure and function, between molecular processes and conscious thought, flowing effortlessly within you. As you breathe, reflect on the elegant complexity of your mind. Each memory, no matter how small or fleeting, is the result of countless biological processes working in concert, shaping who you are and how you experience the world. Let this awareness bring a sense of gratitude and wonder for the intricate systems that operate silently within you every moment. When you are ready, gently open your eyes, carrying with you not only the knowledge of the science of memory, but also a quiet appreciation for the profound intelligence and resilience of your own brain. In embracing this understanding, we see that human memory is not merely a collection of past experiences. It is a living, dynamic system sculpted by genes, cells, and circuits, yet experienced as thoughts, emotions, and insights. By nurturing both curiosity and mindfulness, we allow ourselves to connect more deeply with our own cognitive processes, fostering an appreciation for the unseen symphony of life within our brains.